Hey math kids, today we're going to talk about recognizing growth, and to do that we need to start with there we go. Okay, so let's say we have that, and okay, so we have a few dots, and this is what you'll be given. We're going to call this step 1, step 2, step 3, and step 4. So the first thing I want you to do is to try to figure out the pattern and draw step 4. So we have 1 dot here, we have 4 dots here, and we have 7 dots here. So to go from here to here, we add 3. To go from here to here, we also add 3. So to go from here to here, we want to add 3 more. So it's going to be 1. So I drew that previous step, but then I want to draw 3 more dots. Okay. Another way that is pretty helpful is we just write down the number of dots in each step. And X, I'm going to call my step number, so 1, 2, 3, 4. Here, I'll even mark that in the color. And then the Y values are the number of dots in each step. So 1, 4, 7, and then we didn't know this step yet. But if we look at this, we say, okay, we're going to add 3, and so if we add 3, there should be 10 dots. And if we count that, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have that. Now, if we're adding to go from step to step, then that's a linear function. Okay. Now, I'm going to take a quick screenshot of that because in a different video we'll go further with that. Okay, now we're going to move on to talk about a different type of growth. So this time we're going to start with 1 dot, and then it's going to go to 4 dots, and then that's what we're given. So we have step 1, step 2, step 3, and we need to draw the 4th step. So there's a different type of growth going on. So if we go from here to here, if we try to add, we would add 3, and then if we add from there to there, it's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay. That might be a type of growth, but before, it might be the 3rd type. But before we move on to that, we want to actually see if it works out with multiplication. So to go from 1 to 4, we would multiply by 4. And to go from 4 to 16, we would also multiply by 4. And so that's what our growth actually is. And so to go from here to here, we want to multiply by 4. So what we're going to do to make this a little bit easier on ourselves, I'm going to call these 4 dots right here just a box. And so I'm going to write step number 3 as this. And if I have that, then I just do one of those. And I just do that 4 times. So each box right here represents 4 dots. So I could write step 2 as 1 box. That way you're just not drawing a million dots. Now you can if you want to. Okay, so now we're going to make a table again. So we have X, Y, step 1, 2, 3, 4, just like before. And we had 1 dot, and then we had 4 dots, and we had 16 dots. And so what this is going to be, 16 plus 16 plus 16 plus 16, or 16 times 4, which is 64. Okay, as we go from step to step, we're just multiplying by 4. And so when we have this type of growth, that's exponential. So when we have exponential growth, it's when we're multiplying by the same number over and over and over. Okay. So again, I'll screenshot this so I can use it in another video. Okay. And we have one more type of growth that I want to talk about. That's when we do things like this. So we have 1. Okay, so when we look at this one, we have 1, then we put 2 on the bottom, then we take that previous one and we put 3 on the bottom, and so the next one is going to look like this. So we're just adding 1 more than we did the time before, and if we try to add, we're going to add 2, and then we add 3, and then we add 4. Okay, so it's not linear because we're adding a different number. Now if we try to multiply, it's not going to work out. So 0, this one we would have to multiply by 3, and then 3 to get to, let's see, 3, 1, 2, 3, 4, 5, 6, 3 to 6 would be 2, and then 6 to 10 is, I don't know, there's a number, but it's not working out nice. Now if we do what's called a secondary difference, where we take just these numbers 2, 3, and 4 and say what's the difference between those two, well that's 1, and then 3 to 4 is also 1. Now if our secondary difference is the same, then that represents quadratic growth. And so we can show that by, this is step 1, step 2, step 3, step 4. So if we do x, y, we get 1, 2, 3, 4 for our steps. And then if we look at our growth, we start with 1, then we go to 3, then we go to 6, and we go to 10. And if we look at that, we get the same growth pattern that we've shown. And if we look at the secondary difference, we get a 1. So this is what we're looking for with quadratic. If the secondary difference is the same from part to part, we say that that's quadratic. Just take a screenshot. Okay, so that's about it for recognizing the 3 types of growth that we're going to just talk about in this course. So if you have additional questions, please come to Math Lab. Until then, calculate.